Alright, I've got my RC converted Cheetah glider here again, and if you guys watched the last video, the setup on this is now golden. I've got the balance pretty well where I want it. My roll rate is really good. It's symmetrical to the left and to the right. So if you watch that, I guess we can call this an after action report, because once I complete a project like this, I like to go back and decide if there was anything that I would do differently, if I could do it over again. And so that information will help you guys if you want to do a similar project. I went and I grabbed the battery that I normally fly in this glider. The battery that I like to use is a 2S. It's a GMB 2S, 550 milliamp hour, ADC LiPo. It weighs 34.1 to 34.2 grams. I've got 4 of those. So that's the battery I use. It's a nice snug fit inside the canopy there. I found that battery shelf that I fabricated and put in there did provide some good strength to the foam underneath the canopy. If you guys saw that crash on flight number 5, you know that it hit pretty darn hard. When it hit the ground, it didn't damage the fuselage, the foam in any way. Okay, so my all-up weight with the battery that I want to use is 269 grams. Now, if you guys watched my progress when I was performing this conversion, you know that I didn't intend to build it and have it sub 250 gram. But then I went back and I looked at my thrust numbers on my Racer Star BR 1306, 4,000 kV motors with Gemfan 5x3 ABS props. And if I could keep the weight down around 242 grams, I would have had a 2-to-1 thrust to weight ratio with those motors, and those motors are 10 grams lighter, 5 grams, for each motor, 10 grams lighter total than the 2 BetaFPV 2004 motors that I ended up putting on it. And the reason I had to do that was because I had a bad bearing in one of those Racer Star motors and I didn't have a spare. So I had to go with those on my backup. So if you guys use 1306 motors, that's going to be 10 grams of weight savings there. The other thing that I would have preferred to do was use EMAX 4-gram digital servos. What I had on hand, I didn't have those on hand. What I had on hand were Hextronic HXT 500 5-gram analog servos. Well, I weighed those 2 different servos, and the 4-gram servos are 2 grams lighter than those 5-gram analog servos. And I had to use 3 of those, 2 on the ailerons, 1 for the elevator. That's 6 grams of weight savings right there. And for the rudder, in order to save a little bit of weight, I used a 3.6 gram digital servo for the rudder, and that worked out fine. That worked out fine. If I'd have had my 4-gram servos that I wanted, I would have put those 4-gram digital servos all the way around, and it would have saved me about 6 grams of weight. There's not much difference in weight between the 4-gram servo and the 3.6 gram servo. So that's one thing I would change. The 2 1306 motors, 4-gram digital servos all the way around, that's a weight savings of about 16 grams. The other change that I would make was I noticed there's some wing flexing on it, even with these 2 2mm diameter solid carbon spars that I put in the wings. You can see that they're angled back from the fuselage and they go all the way to the outer extent of the ailerons. So, but I'm still getting some wing flexing. So what I would do over, if I was going to do it over again, is I would add a second set of 2mm solid carbon spars, and I would go right along the leading edge of the wing, underneath the motor mount, right in front of where the servo cutouts are, and I would have extended that about halfway, or 2/3 of the way to the farthest extent of the ailerons. I'm pretty certain that that would have kept the wing from flexing any. That would add about 4 grams of weight to the airframe. I'm estimating that I've got about 12 grams of landing skid on here, with the front landing skid, the tail landing skid, and the 2 wing landing skids on here. Now if you have nice soft grass to land in, you're not going to have to worry about a landing skid system. But where I have to land, I have to have some type of landing gear or landing skid system, or it's just going to tear up the airframe. So I can't get away from that. So that did add about 12 grams of weight to the airframe. So out of that 269 grams, if you've got nice soft grass to land in, that's 12 grams of weight savings you're going to have right there. Okay, so if you were to do the changes, perform the changes that I just spoke about with the 1306 motors, the 4-gram digital servos, if you don't have to have a landing skid system, and if you cut down all of the excess wire that you have going, going from your motors to your ESCs, from your ESCs to the voltage regulator, from the ESCs to the Y cable that goes into the receiver for the ailerons. If you cut back all the excess wiring and just have it at the precise length that you need, depending on where all of your electronics are installed, I think that would probably save about another 5 grams of weight. So with the savings on the motors, the servos, the additional weight of the additional 2 millimeter diameter carbon spars, and no landing skid system, and cutting down the excess wiring instead of having to fold it over like I did, just because I didn't have the time to do everything I wanted to do. You're looking at an all-up weight with that 2S LiPo I spoke about is 240 grams. So you can get this under 250 grams all-up weight and have a 2-to-1 thrust to weight ratio if you do it the way I just spoke about. If I had to do it over again, I would have waited and I would have had those. If your goal is to have better performance than what the 1306 motors will give you, and you're not worried about hitting that sub 250 gram weight, all-up weight on the plane, these 2 Beta 2004 3000 kV motors are absolutely awesome. And even with the weight, with the 12 grams of landing skid weight that I have on this glider, my thrust to weight ratio is 2.5 to 1. It has a vertical acceleration. With the 1306 motors, it will give you a 2-to-1 thrust to weight ratio. It will have unlimited vertical. It's not going to accelerate vertically, but it will have unlimited vertical. So it depends on what you're shooting for. If you're shooting for sub 250 gram with a little less performance, or if you're not worried about going over 250 gram, those motors are awesome. I absolutely love it on here. I've used these motors on 2S, 3S, 4S LiPos, and they're great in any configuration you want to put them in. Okay, so as a bonus, that's what I would do differently on this project, but as a bonus, I have discovered what caused the crash. Now, if you watched the last flight where I think I was on flight number 4, after removing the BIME gyro and the S-bus receiver I had in it, I put in a standard 6-channel Lemon RX lightweight diversity receiver in it, no gyro. So that's what I had in it during the last flight session. And on flight number 4, I think is the one that I published, that's when I had it set up and I had my roll rate just the way I wanted it. The balance felt good. And at that point I was golden on my setup. I went ahead and put 9 flights through it, 9 batteries through it during that flight session. I had 9 batteries that I could use in this glider. And on the 9th flight I had another crash. And so it wasn't the original receiver and gyro I had in it. I read some of your comments. So you were kind of leaning the same way I was leaning, which was it's either the receiver or the gyro, one of the two. Okay, well, what the problem ended up being was actually the voltage regulator. I've never used this voltage regulator before. It's supposed to be able to handle a 2S to a 6S LiPo. It is supposed to provide a constant 3 amps of voltage. I haven't pulled it back out yet after that crash. It was almost identical to the first crash, with one exception, and this is how I discovered that it was the voltage regulator. Is I was flying it exactly the way I was flying it when the first crash happened in my original flight number 5 of that flight session, where I rolled left and all of a sudden it abruptly rolled right, inverted, and then went down and crashed. I didn't have any control over it. Okay, well on the second crash, I had rolled inverted and then the motors and everything shut down. So what happened during the first crash was that the voltage regulator didn't completely shut down, but it caused the receiver and the gyro to reboot. It was just a quick fluctuation in power because the motors were still spinning. The motors didn't shut down, but that caused the receiver and the gyro to reboot, which is why it freaked out. Now, on the second crash, the voltage regulator shut down completely. I was inverted, the motors shut down, there was absolutely no power, and I just had to watch it dive into the ground again. Now luckily, it didn't damage anything again. Tough little glider. So it definitely passes my durability test as well. But now I've got to pull the voltage regulator out and see if the voltage regulator is bad or if some of my soldering is bad on there. I don't know, it could be my fault. I don't want to say yet that the voltage regulator is bad. I'm going to pull it out, I'm going to check all the connections. I'm glad that it wasn't the original receiver or the gyro that was causing the problem. That was my first inclination, the way that it immediately rolled back over the way it did. And I didn't have any control over it because the receiver hadn't come back online and bound back up to the radio yet. And of course I'm sure that the gyro was still initializing when it rolled it back over. So anyway, that's what the problem ended up being, was a power issue. So I wanted to make you guys aware of that. I've tested quite a few of those Bond gyros so far. I've never had a problem with them. I've tested 3 or 4 of those Radio Master R81 S-Bus receivers so far. I haven't had a problem with them. So I'm glad that was not the issue with what happened. So hopefully after this is either repaired or replaced, I'm hoping that will be the last component failure I have on this project, because I've had several of them now. So anyway, that's my hope. That's your bonus. Let you know what was going on with that. So now we all know. So anyway, thanks for watching, and I will see you in the air.